So the next section that we're going to talk about are extreme values. So now we're in chapter 4. We're kind of figuring out what can we do with the derivative, what does it tell us. So what we're going to do are extreme values. So one thing I do want to mention about this section is that whenever we're talking about a value of a function, we're talking about the y value. So a value of a function is a y value. So whenever we're plugging in these x values, they give us a value of a function, which are corresponding to the y coordinate whenever we plot the graph. So whenever we're talking about a value of a function, in your head you want to think y values. We're not talking about x values, we mean what are y values. So in this section, the main focus is absolute minimums of a function and absolute maximums of a function. So two definitions that we need to know. One, we say that f of a, and this is going to be a y value because I've plugged in the point A and I'm getting out a y value. We say that f of a is, is the absolute minimum of a function f of x if f of a is less than or equal to f of x for all x in some interval. So we're saying that f of a, so whatever y value is corresponding to x equals a, is the absolute minimum of the function if f of a is less than all of the other y values. That's what this is saying. Also, we say that f of a is the absolute maximum of f of x if f of a is greater than or equal to f of x for all x in some interval. So this is kind of saying really the opposite of it, that instead of talking about f of a being less than all of the other y values, now we're saying that it's the largest y value in some interval. What does this look like as far as a graph goes? So maybe here's my function. There's my interval from, let's say this is a and here's b. The absolute minimum of this function is the lowest y value. So that would be here. That would be my lowest y value, so that's my absolute minimum. Whatever y value is there, this is my absolute minimum. The absolute maximum is the highest y value, so whatever y value is there will be my absolute maximum. So again, these absolute minimums and maximums, we're saying what's the largest y value and what's the smallest y value that we can take on. So the next thing we need to worry about is how do we find these? So how do we find the absolute minimum and absolute maximum? Well, first of all, it matters if a function is continuous. So we need a function to be continuous. We need continuity. So why do we need continuity? Well, let's say here's my interval from a to b, and it's not continuous. Let's say it looks like something like this. That's not a continuous function. Do I have an absolute max or min? Well, no, because the y values go on forever in the negative direction and forever in the positive direction. So this is why we need continuity when we're talking about absolute maxes and mins. So here's the theorem that we're going to use. A continuous function, so here's that continuity part that I was talking about. Continuous function f of x on a closed interval, so from a to b, takes on both a minimum, and when we say minimum here we're talking about absolute, and maximum, and we're talking about the absolute maximum here, on the interval. So a continuous function on a closed and bounded interval, so a closed interval from a to b. Now it's important that it's closed, because if it's not closed, you could have something happening like we had up here in the picture. So we need it to be closed. It takes on an absolute maximum and minimum. So if that's true, we can find the absolute max and min. Now how do we find it? So how do we find the max and min? Well, to find the max and min, we have to introduce the idea of a critical value. So a critical value, this is our next definition that we're going to need. We say a number c in the domain of f is a critical value if one of two things is true. Either f prime of c equals 0, or f prime of c is undefined. So what is this saying? This is saying that if I want to find critical values, I take the derivative and see where is it 0 or where is it undefined. Now you might be wondering, why are we talking about critical values? So think about the graph of a function. Maybe it looks something like this. Critical values are where the derivative is 0. So that would be here and here. So those would be my two critical values, this a and this b. But I also want to consider something like this. Right? So this is an absolute minimum, but the derivative doesn't exist there. So this is where the derivative not existing comes in. So critical values are where I have the derivative is 0, so I have horizontal tangent lines, or the derivative is undefined. So those are my critical values. Now that we know what critical values are, here are the steps to find absolute max and mins. So to find absolute max and mins on an interval from a to b. Step 1 is you're going to find the critical values. Find critical values. Then you're going to plug the critical values and the endpoints. The endpoints here were a and b into f of x. Thirdly, you're going to read off the max and the min. Remember what I said at the very beginning, maximums and minimums are y values. So basically what we're doing is we're saying that an absolute max or min has to occur at either a critical value or at one of the endpoints. Which makes sense. A critical value is where I have a horizontal tangent line, so it's either going to occur at one of these points or it's going to occur at an endpoint. So we're going to take all the critical values and my two endpoints, plug them in, find which one gives me the largest y value, which one gives me the smallest y value. So that's how we're going to find absolute maxes and mins. So let's do some examples here. Let's find the absolute max and min of the function f of x. F of x here is x over x squared plus 1 on the interval -5 to 0. Alright, so we're trying to find absolute maxes and mins, so the first thing we need are our critical values. So critical values are where the derivative is either 0 or it's undefined, so to find the critical values, we've got to take the derivative. So how do we find the derivative of f? Well, I've got to use the quotient rule. So u prime is 1, v prime is 2x. So my derivative is, let's see, u prime v, so that's x squared plus 1 minus uv prime, so that'll give me 2x squared all over x squared plus 1. Now we can simplify this. In the numerator, I had x squared and then minus 2x squared, so I'll get 1 minus x squared over x squared plus 1. So I found my derivative. The next part is this ever 0 or is it ever undefined? So when is f prime of x equal to 0? if you want a quotient to be 0, that means that the numerator has to be 0. So I set the numerator equal to 0. So I'll get 1 is x squared, which means x is plus or minus 1. So far I have two critical values, negative 1 and positive 1. Now, is f prime of x ever undefined? So a quotient is undefined whenever the denominator is 0. So let's see what happens if I set the denominator equal to 0. So I'll take the square root of both sides. X squared plus 1 is 0. Subtract 1. No real numbers satisfy this, so the answer to this is no. It's always defined. So what are my critical values? So the critical values are negative 1 and positive 1. So that's the first step for finding the absolute maximum of n. So I'm going to find my critical values. Next step, I'm going to plug my critical values and my endpoints into f of x. So remember what f of x was. F of x was x over x squared plus 1. So I'm going to plug in negative 1, 1, and then my endpoints were negative 5 and 0. So if I plug in negative 1, I'll get negative 1 over, negative 1 squared is 1, so I get 1 plus 1 on the bottom, so negative 1/2. If I plug in 1, I'll get 1 over 1 squared plus 1, which is positive 1/2. If I plug in negative 5, I'll get negative 5 over 25 plus 1, so negative 5 over 25. Or sorry, 26, not 25. And if I plug in 0, I'll get 0 over 0 squared plus 1, which is 0. Of these values that I just got, which is the smallest? The smallest would be negative 1/2. So the absolute min is negative 1/2. Again, we don't put the x value, we only put the y value. Of these four values that we got, what's the largest? That would be 1/2. So the absolute max is 1/2. So again, to find the absolute minimum and absolute maximum, find your critical values, plug in your critical values and your endpoints, and read off the smallest and largest. Let's do another one of these. So example 2, let's find the absolute max and min of the function cosine squared x on the interval 0 to pi. Okay, so we're trying to find the absolute max and min, so the first thing I need to do is find my critical values. So to find the critical values, I'm going to have to find the derivative. Well, how do I find the derivative of cosine squared? Well, that's a chain. First function is cosine, second function is x squared. So my derivative is going to be 2 cosine x. The derivative of cosine x is negative sign, so I'll put the negative out front. So I get negative 2 cosine x times sine x. Now I need to figure out when is this equal to 0 or when is it undefined. Well, let's start with undefined. This is never undefined. There's no denominator, there's no radical, so it's never undefined, so I don't need to worry about that. But when is it 0? So when is negative 2 cosine x sine x equal to 0? Well, it's 0 whenever cosine x or sine x is equal to 0. Whenever you have a product that's equal to 0, it's one of them has to be 0. So let's first look at cosine x. Between 0 and pi, when is cosine x equal to 0? That would be when x is pi over 2. Next, when is sine of x equal to 0? That's going to be at 0, so x equals 0, and pi. Okay, so my critical values are 0, pi, and pi over 2. So critical values are pi over 2, 0, and pi. Now I'm going to take all of these along with my endpoints and test them into f. So I'm going to test pi over 2, I'm going to test 0, I'm going to test pi. Now I've already written down my two endpoints, so I'm not going to write them down again. And let's plug them in. So cosine squared of pi over 2. Well, cosine of pi over 2 is 0, 0 squared is 0. Cosine squared of 0, well, cosine of 0 is 1, 1 squared is 1. And cosine squared of pi is negative 1, negative 1 squared is 1. So, of these three values, what's the smallest? That would be 0. So my absolute min is 0, and my absolute max is 1. It doesn't matter that it repeats. All that matters is whatever was the largest one. So my absolute minimum is 0, my absolute maximum is 1. So that's how you find the absolute minimum and absolute maximum. The very last part of this section is Rolle's theorem. So Rolle's theorem is basically a theorem to tell you when the derivative is equal to 0. So when can you guarantee that the derivative is 0? So what it says is that if f of x is continuous on a closed interval from a to b and differentiable, meaning I can take the derivative, differentiable on the open interval from a to b, and if f of a equals f of b, then there exist some number c in the interval such that f prime of c is 0. So Rolle's theorem is basically giving you very strict conditions on when I do have that the derivative is 0. Pictorially speaking, what is this doing? It's saying that I have a continuous function that's differentiable and the endpoints give me the same y value. We don't really know what happens in between, but I know that the two endpoints give me the same y value. Then by Rolle's theorem, there's some value of c where I have a horizontal tangent line, so the derivative is 0. Well, here I actually had 2, but Rolle's theorem guarantees you have at least 1. Right, so it could be something like, maybe here's the repeated y value. So here's my a and here's my b. Then c would be here, wherever I have my horizontal tangent line. So let's do an example of this. Is there a point with a horizontal tangent line, on the function x squared between negative 2 and 2. So can I guarantee that I have a horizontal tangent line of this function between those two values? So horizontal tangent line means the derivative is 0. Well, let's see. I know that f of negative 2 is 4 and f of 2 is 4. This function is definitely continuous and definitely differentiable. So by Rolle's theorem, there exists a c between negative 2 and 2 where f prime of c is 0. So we can guarantee that because the two endpoints gave us the same y value and it was continuous and differentiable. So that's how Rolle's theorem works, is that you need to guarantee that the two endpoints give you the same y value. If you can do that, then there's going to be a horizontal tangent line. So that's extreme values and Rolle's theorem.